Welcome back. In this video, I want to introduce another problem whose solution is the Fibonacci numbers. I call this problem climbing a staircase. So how do we pose the climbing the staircase problem? The question to answer is how many ways can one climb a staircase with n steps, taking 1 or 2 steps at a time? So we have a staircase. We can go climb the staircase as 1 step, 1 step, 2 step, 1 step, or we can climb it as 2 step, 2 step, 1 step. And if we have n stairs in the staircase, then how many different ways can we climb this staircase? To answer this problem, we can make a table. We can have consider a small number of stairs, from 1 to 5 stairs, and we can list the number of ways that we can climb this staircase. So if there's only 1 stair, there's only 1 way to climb this staircase, which is to go up by 1 stair. So we call a sub n the number of ways you can climb n stair staircase. So a sub 1 is 1. If we have 2 stairs in the staircase, then we can climb 1, 1, or we can just climb 2. Go up both stairs at the same time. So a sub 2 then is equal to 2. If we have a 3-stair staircase, we can go 1, 1, 1, 1, 2, go 2 stairs at a time at the end, or we can go 2, 1, 2 stairs at the beginning. And there are 3 different ways we can climb a 3-stair staircase. So we have 1, 2, 3. Looks like we're just counting, right? But if we have a 4-step staircase, then in fact there are 5 different ways. 1, 1, 1, 1, 1, 1, 2, 1, 2, 1, 2, 1, 1, and finally 2, 2. We take 2 stairs first, and then we take 2 more stairs. So there are 5 different ways to climb a 4-step staircase. So now we have the sequence 1, 2, 3, 5. 5 is equal to 2 plus 3, so it's part of the Fibonacci sequence. Let's look at one more. What if we have 5 stairs in the staircase? Then if we list out all the possible ways to climb a 5-stair staircase, we see that there are 8 different ways. So now we're getting the Fibonacci sequence here. 1, 2, 3, 5, 8. Just missing the first 1. So why are we getting the Fibonacci sequence? Can we do some sort of mathematical argument to show you that we should have the Fibonacci sequence? So let me try and do that. So let's think about how to climb the staircase. We can actually break climbing of the staircase into 2 different ways. We can start by climbing the first stair. We can climb by 1 stair, right? And then so on climb the rest of the staircase, okay? The other way is we can start with 2 stairs. So we can start with 2 stairs and then climb the rest of the staircase. So we have those 2 possibilities. The first step we take can be 1 stair, or the first step we take can be 2 stairs. So how many ways are there then to climb an n-stair staircase if the first step we take is 1 stair? Well, there's n minus 1 stairs left, right? We took 1 step already. There's n minus 1 steps left. So the number of ways we can climb an n-stair staircase here is n minus 1 ways, because we've already climb the first step. The number of ways we can climb an n-stair staircase if we take as our first step 2 steps is the number of ways we can climb n minus 2 steps, because we already took 2 steps. So the number of ways here is a sub n minus 2. Okay? So the argument I'm making is that the number of ways to climb an n-stair staircase is equal to the number of ways to climb a staircase where the first step is 1 step, a sub n plus minus 1, plus the number of ways to climb a staircase where the first step is 2 steps, a sub n minus 2. A sub n equals a sub n minus 1 plus a sub n minus 2. That's just the recursion relation for the Fibonacci sequence. That's why we're getting Fibonacci numbers. The difference, though, is we need the initial conditions, so the initial values. So the number of ways to climb a one-step staircase is 1, right? The number of ways to climb a two-step staircase, remember, is 1, 1, or just 2. So that's 2. So these are not the initial values for the Fibonacci sequence, but 2 is a unique Fibonacci number, is the third Fibonacci number. And 1 can be either the second Fibonacci or the first Fibonacci number. Here I'll take it to be the second Fibonacci number. So a sub 1 is f sub 2, a sub 2 is f sub 3. A satisfies the Fibonacci recursion relation. So we must have a sub n is a Fibonacci number, but it's not f sub n. It's 1 more than f sub n. It's f sub n plus 1. Okay? So the number of ways to climb an n-step staircase, taking 1 step or 2 steps at a time, is the n plus 1 Fibonacci numbers. Fibonacci numbers show up in this problem. So we've seen now 2 problems with Fibonacci numbers, the rabbit plot problem, the classic rabbit problem from Fibonacci, and the climbing the staircase problem. In the next lecture, I want to talk about the golden ratio, and then we'll find a connection between the golden ratio and the Fibonacci numbers. I'll see you next time.